Hello, Algebra 2. Long time no see via video. How we doing? We're doing 8.6. It's the last lesson of Unit 8. Last time, long ago, we discussed reference angles. If you don't recall reference angles, what we said was that, okay, if you have an angle, like we know all there is to know about the first quadrant. Okay, we know all there is to know about the first quadrant. But as we migrate around this around the graph here, we start to see duplicates in a way. If here's my graph and here's a 45-degree angle here, and there's the point cosine comma sine, well, over here is another angle that's practically the same thing. This is also 45 degrees here, but the angle is 135 degrees. When you make a 135 degree angle, you are also creating at the same time a 45 degree what we call reference angle. And because of this, this value is the exact same as this one, except cosine is negative on the left half of the graph because x is negative. So this will be negative cosine comma sine. It would be the exact same numbers except negative. Okay? So a coordinate plane is like a visual representation of all of this. So in 8.6, we're basically just tying it all, putting a pretty bow on it. We're just a nice, pretty recap of everything, and that involves the unit circle. So let me fill this in real quick. Let me pause, and I'll be right back. Okay, I'm back. So I filled this in so that way you didn't have to watch me do that. You can pause right now and fill this in yourself. This is a review from the last set of notes, and this is also how we find reference angles from the last set of notes. Okay? So there's a quick summary here, and I'm not sure I really need to read that. Let's just jump into the problem, and maybe we'll reference these directions here in a moment. Okay? So find the exact value. What is sine of 1,110 degrees? Well, we need to, 1,110 degrees is such a massive number, right? We need to figure out what the reference angle for 1,110 degrees is. But before we can even find the reference angle, we should really shrink this degree measure down, right? We know what coterminal angles are, that when you add or subtract 360, you just end up right back in the same spot. So let's take 1,110 and subtract 360 several times. I'm going to do this off screen on a calculator. 1,110 minus 360 gives me 750, but then I subtract 360 again, and it gives me 390. And I subtract 360 again, and it gives me 30. Oh, so 1,010 is essentially equal, I'm gonna put that in quotes, to 30 degrees. So what is sine of 30 degrees? The answer, you look at this chart, 1/2. The answer is 1/2. So 1,110 degrees seems like a very big intimidating number, but shrink it down using the idea of coterminal angles, and once you've found the number, well, then you're on your way. Let's do another one. Cosine of negative 600. Well, you add 360 to make this more positive. Again, doing this on a calculator off screen. I hope that's okay with you, that I add 360 off screen. I add 360 one more time, and I get 120. What is the reference angle for 120? Remember, it's the gap, right? Like when I graph 120, it's somewhere right there, right? Here's 90, and 120 is going to be a little bit bigger. So the question is, how big is this gap right there? Well, if this is 180 and this is 120, there's a 60-degree gap. The reference angle is 60 degrees. Okay? So if you go back and watch the 8.5 video, you'll hear me say this sentence on repeat. Whatever's true about 120 is also true about 60, give or take the positive or negative, because 60 degrees is the reference angle for 120. If we want to know something about 120, we're going to reference 60 degrees. Okay, so let's reference 60 degrees on this table. What is cosine of 60 degrees? Cosine of 60 degrees is a half. So negative 600 is essentially equal, again, air quotes, to 120. And the reference angle for 120 is 60. So I go and reference 60, and I get an answer of a half. You see what I'm saying there? It might seem like a little bit of a process, but this becomes so quick, this becomes such second nature that, I mean, is it really a step? 945, let's shrink this down a little bit. I'm going to, instead of writing minus 360 like 3 times over, I'm just going to do it till I get to a small number. So 945 minus 360 is 585, minus 360 is 225, minus 360, oh, I'm into the negatives now. So I'm going to add that 360 back, and I get 225. So 945 is sort of equal to 225. Those are coterminal angles. But what's the reference angle for 225? You can graph it like this, right, and figure it out visually, or you can use this little trick from the previous notes. Let's do it that way this time. 225 is right here. So I need to do 225 minus 180 in order to find the reference angle. The answer, 45 degrees. So what is tangent of 45 degrees? Or 945 degrees? Well, whatever tangent of 945 is, that's going to be this answer. Oh, I just realized, let me finish. Tangent, so we're in the third quadrant. So tangent is going to be positive. So what's tangent of 45 degrees? 1. So this is going to be 1. I made a mistake on a B. I apologize. I made a mistake on B. Okay? 120 degrees is in quadrant 2. So cosine is going to be negative. So this is a negative 1/2. Sorry. Right, we need to remember what quadrant it's also in. So this was quadrant 1, 30 degrees, so it's positive. This was quadrant 2, so cosine is negative in quadrant 2. Tangent, this was in quadrant 3, so tangent is positive in quadrant 3. Can I ask you to do this one? There will be some answers on screen here momentarily. Sine of 810. You want to find the coterminal angle for 810 and then find the reference angle. So some answers pop up on screen. The coterminal angle for 810 minus 360 is 90. Oh, well, 90 degrees is the reference angle. You got off easy on the question that I asked. 810 is the same thing as 90. Oh, okay, well then let's just jump straight to 90. What is sine of 90? 1. So you should have answered 1. You got off easy on that one. So now we're going the other way around. We're trying to find an angle between 0 and 360 that satisfies this equation. Well, we've used it before already in class. The inverse trig function. The inverse trig function will tell you your answer. The inverse trig function will tell you your answer. When you inverse something, you're going backwards. So you know the trig value, but what you don't know is the angle. So you want to do the inverse. So you inverse it in order to find your solution. Now, it says it has to be an answer between 0 and 360. Okay? Which, let me bring up my screen here. Make sure you're in degree mode. When you inverse sine -1/2, -1/2, it's going to tell you -30 degrees, which isn't wrong. That's not wrong. However, that is not between 0 and 360. So what should we do? We should add 360 to this to find a coterminal angle. And when you add 360 to that, you get 330. 330 and -30 are the same thing. So we just found a positive solution. When you do inverse tangent of 0, making sure you're in degree mode, you get 0. Oh, that is between 0 and 360. That is between 0 and 360. So that one worked out. When you inverse cosine √3/2, do you need a calculator? Let's backtrack. Do you need a calculator for this? No, right? I mean, we have this table for a reason, okay? When is cosine equal to √3/2? Right here. Oh, the answer's 30. I don't have to use a calculator if I have, number one, that table memorized, or if I have that table handy, right? If I have that handy, I can go, well, oh, when is cosine equal to √3/2? Right there. So that the answer, 30 degrees. But I can punch it into a calculator as well, and I'm still going to get the same answer. You want to be careful that you plug this in correctly. I'd hate for you to not do it correctly, but you are going to get 30. So the last one, let's again open the floor here, and some answers pop up on screen. When is sine equal to cosine? That's sort of a unique question. When is sine equal to cosine? I suggest you use the table. Some answers pop up on screen. It's probably clear that cosine and sine are equal at 45 degrees. Also, at what would be down here in the corner, they would both be -√2/2. Did you ever think of that, right? They would also be down there at, what would that be, 225 degrees. Okay? So, there are a lot of these have two answers, right? I only focused on one, but yeah. Find the coordinates of the vertex of a rectangle inscribed in the unit circle for a particular quadrant. So, by the way, we've been beating around the bush here, this idea of a unit circle. I've showed it to you before, but let me just pull it up super quickly. Here's the unit circle. Beautiful, right? So, don't be too intimidated by it, right? Here's our 30 degrees, and here's our cosine, and here's our sine. Here's our cosine, here's our sine, here's our cosine, here's our sine. Why do we use this idea of reference angles? Because, it's a reflection, That's why reference angles make sense. This 30-degree angle over on the right, when it gets reflected across to the left, creates this 150-degree angle. So it's the exact same point, root 3 comma a half, except now because we're on the left, it's negative root 3 over 2 comma a half. So that's why these reference angles works. And when you reflect downwards from 30 degrees to 330 degrees, it's the same coordinates, except now sine is negative down below, so on and so forth here. So that's why this idea of a reference angle makes sense, because visually speaking, it's reflections. We are doing reflections everywhere, and that's why it's mimicking, right? It's like a copy-paste situation, give or take the positive or negatives due to the quadrant that you're in. Okay, so let's try to keep this under 20 minutes. So one of the vertices is at root 3 over 2 comma a negative a half. What are the coordinates of the vertex in quadrant 3? Well, look at the unit circle. So one of the vertices, it says, let me read this again. A rectangle is inside of the unit circle. So root 3 comma negative a half is right, root 3 over 2 comma negative a half is right here. There's part of the rectangle. And so we're making a rectangle, and we want to know, where is the vertex in quadrant 3? It's right here at negative root 3 over 2 comma negative a half. I know that the vertices, due to the reflective nature, I know that the vertices all have to have the exact same coordinate, give or take the positive or negative, right? And in quadrant 3, cosine and sine are both negative. So even without looking at that, I personally know that the answer is this, because I know that in quadrant 3, they both have to be negative. Okay, they both have to be negative. But I mean, you're not obligated to just be able to do it, right? If you need to pull out the picture, then do that, right? Beautiful. There's my rectangle, and there's the 1, 2, 3, 4 quadrants or vertices. All right, last one. One of the vertices is at 1/2 comma root 3 over 2. Can you answer this without even looking at the unit circle? Let's have some, you know what, last one. Actually, this would be really difficult to type, so never mind. No answers come up on screen. What's the coordinates, though? In quadrant 2, we know that cosine is negative and sine is positive. Remember, ASTC. Sine is positive in quadrant 2. This is quadrant 1. All of them are positive. Quadrant 2, sine is positive. Quadrant 3, tangent is positive. Quadrant 4, cosine is positive. So sine is positive in quadrant 2, therefore cosine is negative. So this becomes negative 1/2 comma root 3 over 2. But if we go ahead and look at this, if the first point is at, let's change colors. If the first vertice is at 1/2 comma root 3 over 2, that's right there. And then when we make our rectangle, we're going to create this rectangle. And we have 1, 2, 3, 4 vertices, right? And the one in quadrant 2 is right here. So negative 1/2 comma root 3 over 2. That's my final answer. All right, folks, with that being said, I hope that you take some time to stare at this unit circle and kind of get used to this visual representation. Yeah, thanks for watching. I'll see you in class, and yeah, ta-ta for now.